so if you can please pull out the sheet that you got on organic nomenclature, and we'll fill in the notes together. So first thing I want to do is I want to talk a little bit about organic compounds. And this is its own entire branch of chemistry that's called organic chemistry. And typically you'll take 2 levels of it at the university level if you're a science major, so depending on what type of major that you have. So being that I was a biochemistry major, I actually had 2 levels of the organic. And there's a whole nother system of working out organic. It's very different from how inorganic works. There's a lot of memorization of reactions and things like that. So like a big thing is organic flashcards. There are students who take who do independent studies in organic chemistry here. So I have 4 students right now that are doing an independent study in organic. And it's very different from what we do, whether you're taking inorganic, like the honors chemistry, regular chemistry, or even AP chemistry is still inorganic chemistry that we do. So what element is organic chemistry pretty much based all around? Carbon, okay? And the cool thing about carbon is it actually does covalently bond with itself. And so what do you know that's a really, really strong or hard substance that exists in nature that is carbon-based? Diamond. Perfect. Diamond. Okay. Diamond's made of carbon. So is what is in your pencil? They call it pencil lead. Graphite. Perfect. The other form is coal, also of carbon. And so and then there are the balls that carbon forms chains, and they're called. Anybody know what those are called? They're called buckyballs. Buckyballs. Yeah. Buckminster fullerenes are what they're called. So carbon has its own naming system and all that goes along with it. The only thing that we're going to name are called alkanes, okay? And you've heard of these before. They end in ane. So for example, you've probably heard of methane before. Where have you heard of methane? You can say it?
Gas.
Methane gas. Good. It's the natural gas. Okay, that's called methane gas. Has anybody heard of propane?
Yeah.
Where have you heard propane before? Grill. Awesome. You know, if you go to get the grill tanks, those are propane gas that are inside of there. How about butane? Perfect. Lighters. Like the little lighters too, or the longer lighters, those are butane. Okay. And some of you may have heard octane before also. Where maybe have you seen octane? Where gas? What do you mean gas? At the gas station. Good. If you've ever and now that you're starting to drive, you'll probably like sit there and like read the labels, and you'll see octane, and they have different mixes, different mixtures of the gases. So all that, basically the state requirement right now is for you to be able to name alkanes, and then there's one other thing that they want you to know, and it's what are called isomers. Okay. And so there are 2 major things that we're going to get down today. So organic chemistry is the study of organic or what based molecules? Carbon. And blank is the only element that can make bonds with itself so that chains are produced. What is that? Carbon. Again. Carbon is a main element in everyday life and thus is lucky enough to have a whole subject in chemistry dedicated to it called, everybody? Organic chemistry. Good. Okay, so naming what are called straight chain alkanes. These can branch off with carbons branching off of them, and you can get these huge chains of them. But we're going to just talk about the straight chain alkanes. So naming of straight chain alkanes, which are alkanes that do not, we're going to say they do not branch, is a straightforward process. To give an alkane a name, you use a prefix which is going to indicate the number of, what element's important here? Carbon. Of carbon atoms in the molecule is added to the, what do you call the ending in English in your class? The ending of a name you call the? Suffix. Good. Ane. Identifying both the kind of molecule in alkane and how many carbons a molecule has, which is the prefix. The name pentane, for example. Guess how many carbons pentane has in it? 5. Perfect. So you see the stem penta. That tells you that the molecule is an alkane, thus the ane ending, and that it has 5 carbons. Penta indicates 5. Prefixes for alkanes that have 1 to 4 carbons are rooted historically. These are methane, ethane, propane, and butane. After that, they get to be really easy. So 5 we said is pentane. Guess what 6 is? Hexane. Hexane. Good. 7, heptane. 8, octane. 9, nonane. And 10, decane. Perfect. Okay. So those end up being pretty easy, but the first 4 are hard to remember. So what I'm going to do is I'm going to say either Mary or Matt or Mike, whatever M name you want to use, eats peanut butter. That's what we're going to do for that. So we're going to come back to that in 1 second. And on the other hand, for 5 carbons and up, the prefixes are the same as those for molecular compounds. An easy way to remember the first 4. So it doesn't really matter. Let's use Matt here too. So again, you can use Matt, Mike, any name that starts with Mathis. Okay. So we can do Mathis. Do you eat peanut butter, Mathis?
Sure.
Okay. All right. Sure. So we can do Mathis eats peanut butter. Everybody say it. Mathis eats peanut butter. Okay. What this is the methane, ethane, propane, and butane. Everybody do this with me, so we're going to count the 4 together. So you're going to go like 1 carbon, 2 carbons, 3 carbons, 4 carbons. Here we go. So methane, ethane, propane, butane. And I want you to just say it one more time. So Mathis eats peanut butter. Say it. Mathis eats peanut butter. Okay? So let's flip to the back, and then we're going to come back to isomers. Okay, so flip to the back for 1 second here. I'm going to come back to these ones. All right. There's a formula for these. It's really easy. It's CN, meaning your number of carbon atoms, and then they have hydrogen in them. And what you do is you do 2 times N plus 2. But I'm going to show you a really easy way to do this. Okay. So this is your number of carbons, and then you do 2 times however many of carbons you have plus 2, and that's how many hydrogens it is. But watch how easy it is. The carbons are going to have plus signs going around them, and every single end of that is a hydrogen. So for example, let's say that I had 3 carbons. Okay, so let's just guess. Let's say that I had 3 carbons in there, and I made a chain of 3 carbons. So you would go 1, 2, 3. Each one of these is called, anybody know what that line is called? That dash is called?
A chain.
Starts with a B? A bond. Perfect. And what the bond represents, we're going to talk about later on, is 2 electrons. Each one of these dashes represents 2 electrons. Okay? And so these are bonded here. And what happens then is you're going to make a plus sign going around each carbon so that each carbon has 4 bonds going around it. Okay? And guess what you add going around all of that? H's. So you're going to go H, 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 going all the way around. And now if you counted, each carbon then has 2, 4, 6, and then the 2 at the end are those 2 that you're adding. Okay? So that's 6 plus 2 is 8, and the formula you would write as C3H what? H8. Okay, well times 2 and then plus 2. Okay, so that's your times 2, because each carbon gets 2 hydrogens, and then you add 2 for the 2 on the end. Pretty easy? Okay, you can either remember it based on the formula. The state wants you to be able to both draw and name, okay, and write the formula for it. So now let's name it. If you have the first carbon, we said, say it with me again, this little saying, it's Mathis, oops, sorry, no, I'm writing an M. Oh, that's good for the name. Mathis, then what? Eats what? Peanut butter. Good, nice, I'm hearing this. Okay, so the M is for methane. Nice. The E is for ethane. Then the P? Propane. Be careful and not to use pentane. But an easy way to remember it is you know that penta is 5. So that should be pretty easy to remember. And then B down here is butane. Okay. So let's keep going with this just to make sure that we have all of these down, these names. So then it goes, 5 would be pentane, 6, hexane, then heptane, octane, and then what would 9 be? Nonane, and 10, decane. Okay. So let's do a couple of these as far as the formula goes, and then you'll be able to fill in the rest of them on your own. So let's do methane. Now again, you don't have to use the formula because I'm going to tell you, if you draw it or if you picture the drawing in your head, it makes it really easy. So for example, if I know that this just has one carbon, then you're going to do your plus sign going all around it. So you have 2 attached to each carbon and then 2 at the end. And what do you put in there? Hydrogens. Perfect. So those are your H's. So the formula would be C, and then what?
1.
C, right? And you don't have to write a 1 down. H, how many? 4. Perfect. And that's methane. CH4. Okay? Now let's do ethane. So what you're going to start off doing is putting your 2 carbons in there. So there's your your 2 carbons, C2. And then again, you have 2 hydrogens on each one, and then at the end, so a plus sign going around each carbon, and again, H's going all the way around. Does that make sense? Formula then would be C2H6. Awesome. Times 2, and then add the 2 from the end, on the ends. I lost some of these H's in here. Okay, now let's just go down and do one more, and then you can fill this in yourselves. Let's do octane. Okay, do you want to do the formula first or the structure first? Structure doesn't really matter. Okay, remember, if you're doing the formula, you would write C8, double it, and what? Add 2. So if you double it, you get 16, add 2, and you get 18. Nice. So you can see that you can very quickly get the formula for it. So then you're going to go 8 carbons. 2, 3, 4, 5, 6, 7, and 8. And then do all your hydrogens going all around. You can see that it takes time. There are faster when you learn organic chemistry. There are other ways where they actually just use lines for the carbons, and they kind of look like branches, and then they don't show the hydrogens because we know that those hydrogens are around. But for this first level of just naming the alkanes and getting the structures down, it's a good idea to draw these in just for the sake of getting it to sink in. Okay, let's flip back to isomers real quick now. Okay, so isomers are different compounds with the same formula. Because these are different compounds, they react differently, so they have to have
The same amount of.
but what about their names then? If they react differently,
Different.
different names. Perfect.
I don't know what that means.
So their names have to be different.
Good job.
We've learned the names of alkanes 1 to 10. These alkanes do not always form straight chains. So alkanes do not always form straight chains of carbons like butane. And it says you will not need to name the isomers. You only have to recognize that that the compounds are isomers. Okay? So just keep that in mind. Count these. How many carbons do you have here?
4.
4. Count your H's. How many H's are there? So times 2 plus 2 would be 10. Perfect. And it does have 10. They're calling that N-butane. Okay, again, you're not going to have to worry about the names. You just need to be able to recognize isomers. So now let's count here. How many carbons are there? 4. Go ahead and count your H's. And how many H's? 10. The formula for this is C4H10, and the formula for this is also C4H10. But these actually react differently, so their names are different. We call them isomers if they have the same chemical formula, but a different structure. That's it, okay? So it says many times there are branches that come off from this long chain. An isomer is a molecule that has the same, what?
Same formula. Different.
What kind of formula? We call that the chemical formula. Awesome. The same chemical formula, or same number of carbon and hydrogen, so same number, but they have different structures. Awesome. Since these two structures are different, but the formulas are the same, we call them isomers. Remember how we said we had isotopes, and we said isotope, isoprot? Again, we're seeing the isomers now, so these are the same, okay? They have the same structure. I'm sorry, the same formula in different structures. Okay, so let's flip to the back page. So now the question is, can you name these? Okay? Then you're gonna write the formulas of these. So for example, octane would be C8, and then times 2 plus 2, so
18.
H. Perfect, so 16 plus 2 would be 18. Nice. Here you're gonna write the formula on the line and then you're gonna draw it, okay? So you'll write what ethane's formula is and then draw it using your carbon chain. So remember, it's gonna have, if it's ethane, then Mathis, what? Eats, that's ethane. So it's 2 carbons, and then don't forget to put all of your hydrogens in there, okay? And then you would write the formula for it. You can do it before or after, whatever's easier for you. Okay. An isomer we talked about here, you can fill that in. What I want you to do is, let's do this one together real quick here. So I want you to write the formula for A, B, C, and D. So I'm going to give you a second to write the formula for each one. So C something, H something for each one of these. So for example, this one would be C4, what? H10. Okay? So write the formulas, and then don't say anything. What's going to happen is on the count of 3, I'm going to have you tell me which 2 are isomers. Okay? On the count of 3, you're going to tell me which 2 are isomers. Okay, so B's formula is
C4H10,
H10. How about C?
C5H12,
And how about D?
C6H14.
Okay, on the count of 3, which 2 are isomers? 1, 2, 3.
A and B.
Perfect, A and B. Okay, so you would say A and B on that. And then you're going to just finish off this worksheet and